This is the most famous identity in maths, but how do we prove it? Sine squared theta plus cos squared theta is equal to 1. Well, let's start with a diagram of an x and y axis, and we're going to pick a point P. We're going to give it the coordinates x and y, which means you go x along and y up. We're going to call the distance from the origin to P r, which now means we have a right angle triangle. We can use Pythagoras' theorem that x squared plus y squared is equal to r squared. We also have an angle between the x-axis and the line OP. With that angle, we can use SOHCAHTOA to say that x is equal to cos theta times by r, and y is equal to sine theta times by r. That is using adjacent over hypotenuse and opposite over hypotenuse. We can now implement these into this equation and use Pythagoras to say that instead of x, we can say r cos theta. So r cos theta squared plus r sine theta squared is equal to r squared. I've just substituted the x and the y with these equations here. We can expand these brackets to get r squared cos squared theta plus r squared sine squared theta is equal to r squared. You can see that we have an r squared on both, so we can take out the r squared by factorization, and we get cos squared theta plus sine squared theta is equal to r squared. You can see we have an r squared on both sides, which we can now cancel out, and we get cos squared theta plus sine squared theta is equal to 1. And to get it into the form that we started in, we just swap these two around. So sine squared theta plus cos squared theta is equal to 1. And this is our identity, the most famous identity in maths. And this is the proof.